Okay, sorry, tadi it dah reach limit 15 minit. Okay, this is the mechanism in protonic acid, which is the mechanism in overall of cationic polymerization. Okay, Ha here is the proton and counter ion. It is the resulted from the dissociation of initiator. Okay, yang saya tunjuk tadi. Yang ini. Kan? Yang ni adalah Ha lah. Which is H is the proton and BF3OH which with the negative charge is a counter ion. Kita panggil counter ion. Alright. So proton and counter ion in association will react with monomer to produce stable covalent bond. So we can see here direct the direct addition of proton here H plus to the olefin ataupun kepada monomer ni. H plus will be donate to the monomer. Okay, so we can get this structure. So cationic polymerization, kita panggil cationic polymerization because the presence of the positive charge at the carbon atom here. Okay, so positive means the loss of the electron. Compared to an ionic polymerization, the carbon here with a negative charge. Okay, for cationic, it will left with positive charge. Okay, so bila H plus which is proton ni dia attack monomer, dia akan jadi CH3 kat sini. Lepas tu dia akan jadi single bond lah. Okay. So donate proton to olefin to form proton species. Polymerization occur if the proton species in possible concentration. Common acid use of phosphoric, sulfuric, and so on. An ion which is negative ion or ion pair must be high nucleophilic to prevent the formation of covalent compound. Okay, so the halide counter ion rapidly combine with carbocation active center. So it will form stable covalent bond. So carbocation active center ni yang ni lah kita panggil carbocation active center. Only low molecular weight polymer are formed with these initiators. Alright, next slide. Some mechanism for carbonium ion salt. Yang ni dia tak payah post lah. Okay, we will pay attention more on the Lewis acid. Okay, Lewis acid also called as a Friedel-Crafts mechanism, which is Friedel-Crafts reaction. The reaction conducted at low temperature, which is less than negative 70 degrees C, and the reactivity of catalyst dependent on the co-catalyst, so the strength of acid or co-catalyst affecting in polymerization rate. For example, the polymerization of isobutene with SnCl4. And the polymerization rate dependent on what types of co-catalyst used. Okay, so not all the initiator require co-catalyst. Some initiator, for example, manganese MnCl3, do not require a co-catalyst because it is a strong initiator. So basically, the Lewis acid, for example, in this list, it will act as a proton donor or cation source, which is H2O alkyl chloride. So kita akan guna water je lah, senang sikit. Okay, kita tengok contoh ni. Polymerization of styrene by using BF3. Okay, BF3 is the boron trifluoride as initiator. So yang ni yang paling senang untuk awak ingat lah, untuk awak tulis. Initiation by Lewis acid proceed faster in the presence of either a proton donor such as water. So ini adalah step dissociation. Okay, dissociation of initiator. Okay, ni BF3 ni adalah initiator dia dalam Lewis acid type of initiator. Okay, kita akan pay attention untuk Lewis acid sahaja. Photonic dengan stable cation tak payah. So BF3 initiator akan react dengan water sebagai co-catalyst and then it will produce H plus which is the proton, and together with BF3OH minus which is the counter ion. Okay, so we call it, both of this is proton and counter ion pair lah. So next step, the propagation. Sebenarnya dia dah skip satu kat sini, association kan. Association dia tak tunjuk. Association ni biasanya reaction of this, okay, HO BF3OH plus H3 dengan monomer. Okay, dia akan react dengan monomer. This is the association with the monomer. Okay, just copy the reaction above and we react with the monomer, and then the H plus will be transferred here. Okay, it becomes CH3 and we also tend to be single bond, right? And don't forget the positive charge here and negative charge here. So BF3OH kita akan bawa ke belakang sekali. So make sure CH3 H kat sini dia akan pindah sini, akan jadi CH3. Okay, so the loss of the double bond in the presence of the positive charge at the carbon atom, which is we call it as counter ion. Alright, next step, propagation, which is the addition of monomer to the active center. As we can see here, CH3, CH, BF3OH will be reacted with the monomer again. And cara nak tulis reaction dia, CH3, CH, okay, BF3 ni memang kita bawa dia ke belakang, okay, memang duduk ke belakang, bawa salin je CH3, CH sini, and then salin balik yang ni, CH2, CH, make sure dia tak ada double bond, dia akan jadi single bond, and then sebab dia propagate, so dia tulis N kat sini many times, and numbers. And kalau awak tak tulis yang ni pun tak apa, yang ni pun sampai sini pun dah cukup. So make sure awak tak tinggalkan dia punya positive charge ni. So H ni nak tulis kat sini pun tak apa, nak letak kat atas ni pun tak apa. Okay, so don't leave the positive counter ion and don't leave the BF3OH. This is the propagation. Senang sangat. And the termination dia ada dua, which is termination by unimolecular and the other one by chain transfer. Okay. For example, the transfer of a proton to counter ion monomer, polymer, solvent, or some other added reagent can terminate the reaction. Transfer to counter ion in the styrene BF3 water system is illustrated by, so ini awak salin balik daripada reaction yang tadi, reaction propagation tadi, yang ni salin balik, and then dia akan jadi double bond kat sini sebab the transfer of a proton to counter ion. Okay, so this is the termination by unimolecular reagent. Okay, so double bond kat sini and then H plus with BF3OH. This regenerates the original initiating species, which can then reinitiate polymerization as an active catalyst. Right. Lagi satu dia ada propagation ataupun termination by chain transfer. So kalau yang chain transfer dia akan produce double bond dengan single bond. Okay, ni example 2, which is polymerization of isobutylene by using aluminium trichloride AlCl3. Okay, we look at the first step, which is dissociation. So yang tadi BF3, yang ni AlCl3, sama juga step dia. So aluminium atom in AlCl3 is sharing electron pair with only 3 other atoms. Okay, so skip. Ni step dia yang kedua, which is association. Kita tengok bila dia react dengan monomer, dia akan produce CH3, C positif, okay, and CH3, CH3. So, kalau nak senang, kena tulis balik supaya kita ingat step dia. Okay, saya dah lukis balik, senang untuk korang nampak step dissociation dengan step association dia. Sebab yang dia buat ni macam confusing sikit. So H plus here is proton here, and Al, Cl3 together with OH minus, and will be reacted with the monomer. Dia akan produce structure yang ni. Okay, so next step is the propagation. Dia akan dapat macam ni lah. So salin balik yang daripada ionization tadi, dia akan react dengan monomer balik. So CH3, CH3 yang ke depan ni adalah daripada yang kat sini, salin balik yang ni. And then CH2 C ni yang daripada sini. Okay. So salin balik yang ni daripada sini, cuma dia tak ada double bond. Okay, dia kena ada single bond. And then it will be react with monomer again to form poly with n numbers. Okay. So jangan tinggalkan dia punya BF3OH. Bukan BF3OH. AlCl3OH. Okay, saya silap tulis ni. So yang ni AlCl3OH. Okay, gantikan yang kat sini. Kat sini pun sama. Tak tinggal tulis AlCl3OH. Jangan lupa tulis kat sini sekali. And next for termination. Yang kat sini pun saya tersilap tulis AlCl3OH. Okay. For termination, it can be either by unimolecular or by chain transfer. And how to draw the mechanism in termination by unimolecular is awak kena letakkan double bond kat sini, okay? Sebab dia dah tak ada positive charge kat sini, cation tak ada. So mesti cukupkan dia punya carbon jadi 4 So letak double bond, jangan letak H, okay? Letak apa nama orang panggil, proton pula, double bond. Ni mana dia kata kat sini, transfer of proton to counter ion. So transfer of proton to counter ion, dia pergi dekat bond, dia bukan the presence of hydrogen atom, dia pergi dekat bond. Okay, so this is by unimolecular. So yang kat sini AlCl3 tukar, bukan BF3OH. And for by termination by chain transfer, it will produce 2, which is one with the double bond and second one with the single bond. Okay, macam mana nak lukis dia, sama je yang ni sama, cuma yang dekat sini awak salin je yang dekat depan ni CH3 and then don't forget AlCl3. Okay, AlCl3OH yang daripada sini. So senang je. Okay, done. Okay, yang ni a bit confusing dia punya ni. So kalau nak senang nampak, tengok structure yang tadi lah. Okay, this is the overall reaction polymerization of styrene with perchloric acid. Okay, you can see both of the termination either by unimolecular and by chain transfer. So make sure you get familiar with the mechanism. You have to practice more how to draw the mechanism. This is the isobutylene polymerization overall reaction yang kita tunjuk tadi, yang saya tulis, yang saya lukis balik. Okay, yang ni yang ditunjuk ni termination by unimolecular arrangement. Okay, propagation reaction, the cationic mechanism may be influenced by solvent effect or polarity. So yang ni you all boleh baca sendiri. Temperature, so on lah.